to everyone, my name is David Bovard, and the title of my presentation is Aerosol from a heated tobacco product has less effect on liver detoxifying enzymes than cigarette smoke. As you have seen from the title, the topic of my presentation is about the liver. This organ is involved in the production of albumin, bile, it stores vitamins, it also processes glucose and detoxifies xenobiotics. For this last function of the liver, the first step of detoxification is performed by a family of enzymes named cytochrome P450. This family is composed of 57 different enzymes, with each of them detoxifying specific substrates. I give you here two examples of these enzymes. So you have CYP3A4, which metabolizes caffeine, paracetamol, and you can also see CYP1A2, which metabolizes diazepam amiodarone. You can also see that these two enzymes, they have a common substrate, which is clozapine. The activity of these enzymes can be modulated by many substances to which we are daily exposed. I give you here again two examples. You can see that CYP3A4 is inhibited by grapefruit, but CYP1A2 is activated by cigarette smoke. This modulation can be problematic when a person is exposed to several substances at the same time. On this slide, I give you an example. In non-smoker, so people who have a normal CYP1A2 activity and that are under clozapine medication, they will metabolize the parent compound, which is also the active compound, into non-reactive metabolites. In smokers, as we have seen, the activity of CYP1A2 is increased, which means that people under clozapine medication will need to intake more clozapine to have a similar effect as in non-smokers. If a smoker stops smoking, he will need to adjust the clozapine intake to match with the CYP1A2 decrease in activity. If it doesn't, there is a risk of over-medication with potentially harmful effects and even death. To prevent potential interaction with drugs, it is important to screen whether a product interacts with CYP enzymes. We, for example, question whether liver CYP enzymes are also affected in users of a tobacco heating system marketed under the brand name IQOS and referred to as THS for the rest of the presentation. So the aim of our study was to develop a physiological in vitro aerosol exposure system to detect the potential effects of aerosols on liver tissue viability and CYP activity. Our exposure system is composed of a 3D liver model. We used liver spheroids, which is the test organ, the organ on which we want to see a change in CYP activity. We used a 3D lung model, in this case bronchial tissues, which is the entry route for the aerosol. We used a multi-organs on a chip device, the vitrofluid. I will come back on this device in the next slide. And a direct aerosol exposure system, the Cultex RFS. I will also explain a bit better this device in the next slide. The system we developed should answer the following questions. Can we mimic in an in vitro system the effect of cigarette smoke on liver tissues as observed in smokers? What are the effects of heated tobacco, THS, on CYP enzymes in the liver? As mentioned earlier, we used the vitrofluid chip. The vitrofluid is a multi-organ on a chip device, which is used to connect two different in vitro models by using a chip plate and a peristaltic pump. We use this device to co-culture lung and liver tissues. As I mentioned earlier as well, the Cultex RFS has been used to expose our 3D air-liquid interface tissues to cigarette smoke or to THS aerosol. As a first step in the development of our aerosol exposure system, we determined the maximal subtoxic dose of cigarette smoke and THS aerosol to which the lung tissues could be exposed. We proceeded as follows. We first exposed the bronchial tissues to a dose range of cigarette smoke, THS aerosol, or fresh air using the Cultex. We then placed the tissues in the vitrofluid with their respective cell culture medium and incubated the tissues for 48 hours in the chip before we measured their ATP content. And we also measured the level of LDH in the cell culture medium, it's a marker of cytotoxicity. For all the data that I will be presenting on these slides, but also on the next slides, we always compared the results obtained after cigarette smoke or THS aerosol exposure with the data obtained in air-exposed samples. We observed that cigarette smoke was cytotoxic at doses above 16 puff, as it reduced the ATP content in the bronchial tissues and increased the secreted LDH in the medium. In comparison, the THS aerosol exposure did not affect tissues viability, even at doses equal to 56 puff. On the basis of the dose range, we decided to use up to 16 puff of cigarette smoke and 56 puff of THS aerosol. Using the maximal subtoxic doses of cigarette smoke and THS aerosol, we developed an exposure method to detect effects on CYP activity in the liver tissues. As you can see on the left image, we first moved the bronchial tissues into the Coltex RFS system and exposed the tissues to cigarette smoke, THS aerosol, or fresh air. We then moved the tissues to the vitrofluid chip with the medium. At the same time, we also placed 30 liver spheroids in the second compartment of the chip and incubated the two tissues for 24 hours with medium flow. After the 24 hours, we exposed the bronchial tissues again using the Coltex RFS to THS aerosol or cigarette smoke before placing the tissues back in the vitrofluid. After 48 hours of incubation, we measured CYP1A1, 1B1 activity in the bronchial tissues, CYP1A1, 1B1, CYP1A2, and CYP3A4 activities in the liver spheroids. And we also measured LDH in the medium. As you can see, and using this approach, we did not detect LDH in the medium, confirming the absence of cytotoxicity for the 3 doses of cigarette smoke and the 2 doses of THS aerosol tested. In the bronchial tissues, we observed a strong CYP1A1, 1B1 induction after the exposure to cigarette smoke. As CYP1A1, 1B1 has a high activity in the lung of smokers, it confirmed that our cigarette smoke exposure was successful. You also see that THS exposure did not affect CYP1A1, 1B1 activity. We then tested the activity of CYP1A1, 1B1, CYP1A2, and CYP3A4 in the liver tissues and found a dose-dependent increase in CYP1A1, 1B1 and CYP1A2 activities after exposure to cigarette smoke. While CYP1A1, 1B1 activity was increased only by 20% after cigarette smoke exposure, CYP1A2 was increased by up to 150% when compared to the activity in the air-exposed tissues. CYP3A4 activity was also induced by cigarette smoke, but the effect was weak and dose-independent. THS did not cause any significant effect to CYP1A1, 1B1, and CYP1A2. There was a slight decrease in CYP3A4 activity after exposure to the THS aerosol. As the method developed was resulting in robust data with similar in vitro effect as observed in smokers, we tested 3 other CYPs. We did not detect any effect of cigarette smoke exposure on CYP2B6, CYP2C9, and CYP2D6 activities. While CYP2B6 and CYP2C9 were not impacted by THS aerosol exposure, we detected a small decrease in CYP2D6 activity when compared to the air-exposed samples. Because we use bronchial tissues for the exposure to cigarette smoke or to the THS aerosol, we also evaluated CYP activity in those tissues 48 hours after the last exposure to cigarette smoke, THS aerosol, or fresh air. And we observed that after cigarette smoke exposure, in addition to CYP1A1, 1B1 induction reported earlier, CYP1A2 was also induced by 4-fold in the lung tissues, and we also observed a decrease in CYP2B6 and CYP3A4 activities when compared to the air-exposed tissues. No significant effect was observed in the lung tissues after exposure to THS aerosol. As a summary of our study, we have observed that using our physiological aerosol exposure system, we detected an induction of CYP1A1, 1B1, and CYP1A2 in the lung tissues. And cigarette smoke induces CYP1A1, 1B1, CYP1A2, and CYP3A4 in the liver tissues. These in vitro data match the in vivo data from the literature, although the CYP3A4 inhibition was only reported in rodents. THS aerosol, at doses 4 times higher than cigarette smoke, did not cause any cytotoxicity. It slightly decreased CYP2D6 and CYP3A4 activities in the liver and had no other effect on CYP activity. Because THS has less effects than cigarette smoke on CYP activity in lung and liver tissues, THS users are less likely to suffer from drug interaction than smokers. This is the end of my presentation, and I would like to thank all the people present on this slide for the help during the study and you for your attention. Thank you.